Now let us consider this particular example. So this is the graph with 5 vertices what we are having. So and this is the initial distance vector. So 1 to 1 will be 0, 1 to 2 is equal to 6 and 1 to 3 is equal to 5 and 1 to 4 is equal to 5 and 1 to 5 there is no distance, so let it be an infinity. So that is the initial distance vector what we are having. Now after that one that is we in the algorithm you had no, so for k is equal to an 2 to this is the initial distance vector. Previous to this we had one more for loop, no, that is this one, and now 2 to n minus 1. Now what I have to do for each of the u, for each u which is not a source vertex, so that is 2, 3, 4, 5. So these are not the source vertices. So for each of the u which is not a source vertex, what I need to do, I have to check are you having any of the incoming edges. 2 is having incoming edge, 3 is having incoming edge, 4 is having incoming edge, 5 is also having an incoming edge. So for each of the incoming edges, I have to check whether the previous distance is the minimum or through that particular edge, through that incoming edge is the path is the minimum. So now I will check it for the vertex 2. Now I will check it for an vertex 2. Okay. So now it is according to your formula, it is mean of previous distance. What is the previous distance you are having to the 2? That is 6. It is d1 of u. U is nothing but the 2. Okay. And mean of, this is the formula I am writing. It is minimum of for each of the incoming edges. How many incoming edges you are having? You have to write it for that. So it is d1 of the I plus d1 of or d of u I to u. So whichever is minimum. For each of the incoming edge you need to repeat this one. This is the formula I am writing. Okay. This formula I wrote it while explaining previously. So this is the formula. Okay. Now according to that I will write. This has to be repeated for each of the incoming edge. Okay, what is now mean of, what is the previous distance to the 2? It is 6. 6 comma mean of, how many incoming edge the 2 is having? 2 incoming edges there. One is from 1 and one is from the 3. Now I will consider from 1. What is the distance till 1? It is 0 plus this distance is 6. Okay. Then one more incoming edge is there, that is this 3 to 2. What is previous distance to the 3? Previous distance to the 3 is 5. Okay. Minus the distance from 3 to 2 is minus 2. Okay. Got it? Now it is mean of 6. This is 6. This is how much? It is 3. Which is the minimum among 6, 6, 3? 3 is the minimum. Now only don't update here distance to the 2 as a 3. Don't touch this one because this is a previous distance vector. So now I am finding the next distance vector. Once I will find out for all of them, then I need to write. Now only don't take this 3 and update it here. Okay, getting my point. So once I will find out all of them, then I have to write it. Now only immediately don't update it. Okay. Then same thing you do it for this also. So it is again I will not write the formula. So it is mean of what is the previous distance to the 3? 5. Okay. Now mean of for each of the incoming edge you need to do. How many incoming edges there for the 3? 2 is there. 2 incoming edges are there. One is from 1. So distance till 1. Distance from 1 to 3 is 5. Next one more incoming edge is there from 4 to 3. Therefore distance till 4. What is the distance till 4? It is 5. Then minus 2. 4 to 3 is minus 2. So which is minimum among this? It is 5, 5, 3. So distance is 3. Don't update the distance to the 3 as a 3 immediately. Okay. We are not come out of the for loop here. Okay. We are not come out of this for loop. Still we are in the 2 only. Still we are in the 2 only. Once I'll come out, then I have to update. Okay. Now immediately don't update it. Now for the 4. So it is min of, what is the previous distance to the 4? 5. How many incoming edges are there to the 4? Only one incoming edge there. Therefore, no need of writing the min. Otherwise, you want to write. Okay. So, only one incoming edge is there. So, distance till 1 is 0 plus distance from 1 to 4 is 5. So, minimum is 5. Minimum is 5. Now, to the 5. So, it is previous distance to the 5. What is previous distance to the 5? Infinity. This one. Then min of how many incoming edges you are having? 2 incoming edges are there. So what is previous, that is from 2 and from 3. What is the previous distance to the 2? Previous distance to the 2 is 6. Look at here, okay. So it is 6. So that's why I told you don't update it immediately. If I'll update it immediately after getting the distance to the 2 as a 3. So now if I'll update here it as a 3 immediately, then while considering here I'll consider it as a 3, not as a 6. Okay, that's why I told you don't immediately update it. Okay, previous distance to the 2. What is previous distance to the 2? It is 6, and 2 to 5 is minus 1. That is for one incoming edge. One more incoming edge is there from the 3. So what is previous distance to the 3? It is 5. Then distance from 3 to 5 is 1. So it is 6. So which is the minimum distance? 5. 6 minus 1, 5. Okay, this is 6. Okay. So how much the minimum distance is? 5. Now once if I find all of them, then you update. D2 of the u is equal to 1 to 1 will be 0 only. So 1 to 2 is now 3. 1 to 4 is, 1 to 3 is 3. 1 to 4 is 5. And 1 to 5 is 5. Okay. Now what is this indicate here is, so 1 to 2 was previously I was going like this. Now I am going like this. 1 to 3, 3 to 2. So it is 3. Means earlier I was going with one edge apart. This one indicate one edge apart if I'll consider single edge. This is the distance 6 to the 2. Now here 2 means 2 edge apart if I'll go. That is one edge I am considering 1 to 3. Then one more edge 3 to 2. So if I'll go 2 edge apart if I'll take. So 5 minus 2 is 3. That's why it is 3. So previous distance to the 3 was 5. Means direct distance I was taking. Now it is 3. 3 how I am getting? So it is 1 to 4 and 4 to 3. 1 to 4, 4 to 3. 5 minus 2, that is 3. Okay, 2 edge apart if I am going. Then previous distance to the 4 was 5. Now also it is 5. There is no change because here you are having only one edge apart. There is no 2 edge apart you are having to the 4 like how you are having it for a 2 and the 3. That's why no change. Now what is my previous distance to the 5 infinity. Now how I am moving it as a 5 means 6 minus 1. It is 6 minus 1. Okay, if I'll go like this, it is 6. But here if I'll move like this, it is 5. So it is 5. So how we got that one? So it is min of infinity. Previous distance means of each of the incoming edge. Each of the incoming edges means 2. 2, what is the previous distance? 6. Like that we got it. So now once if I'll get all of them, then you update this one. Now this is same concept of the dynamic programming only I am using. So first I am calculated this, stored it in a table. It is a single dimensional table. That's it. Now I am using this in order to compute this. Now I have stored its result in one table, single dimensional table. Now I am using this one for a next iteration. That is for d3 of u. I am using it for a next iteration. Again I'll compute this. Again I'll use that one for the next iteration. So that is d4 of the u. So when it will stop 2 to n minus 1. What is my n value? 5 vertices are there. So n is nothing but 5. 5 minus 1 is 4. So only till 4 I need to compute. Further not required. Further not required. So that is what we have computed it for the 2. Now I'll compute it for the 3. You don't erase and write it. You have to write it separately. Okay. Now I am computing d3 of the 2, d3 of 3, 3. So again the same concept will be applied. What is that one? For each of the u which is not a source vertex. Which are the not source vertex? 2, 3, 4, 5 are the source vertex. Check that whether there is an incoming edge or not. Same formula. Same formula you will be applying. Okay. So now I will compute for this. Okay, it is min of. Now what is the previous distance to the 2? Don't consider now this one, because this already I have used for computing this. Now you take these distances. Now you consider these distances, not this distance, because d3 of the u I have to use the previous distance, means this one I need to use, not this one. Okay. So what is the previous distance to the 2? It is 3. Okay. Now min of, how many incoming edges there for the 2? There are 2 incoming edges are there. One is from 1 and one is from the 3. Now what is the previous distance to the 1? 0. Okay. 1 to 2 is 6. Now from 3, what is previous distance to the 3? What is previous distance to the 3? Not 5 it is 3. So it is 3. Now 3 to 2 is minus 2. So which is the minimum among all of them? 1 is the minimum. 1 is the minimum. Means now how I am moving from 1 to 2 is, I am moving like this. Okay. We are moving 1 to 4. 5. 5 minus 2 is 3. 3 minus 2 is 1. So that's why I got it as a 1. Okay. Now I'll compute for this. So it is min of previous distance to the 3. It is 3. This one, not this one. This one. 3, comma min of, for each of the incoming edge. How many incoming edges are there for the 3? It is 1 from the 1 and 1 from the 4. So from 1 it is how much? From 1 it is how much? 0 plus 5. Then from 4 it is, what is the previous distance to the 4? It is 5 only. So 5 minus 2. 5 minus 2 is 3. So there is no change here. It is 3 only. Now it is min of. Now what is the previous distance to the 4? It is 5. That is this one. Okay. Now how many incoming edges you are having? So since there is only one incoming edge, that is from 1, that is 0 plus 5. So there is no change. It is 5 only. Now what is the previous distance to the 5? Previous distance to the 5 was 5. Now how many incoming edges are there for the 5? There are 2 incoming edges are there. So one is from 2 and one is from 3. What is the previous distance to the 2? Previous distance to the 2 is 3. So it is 3 minus 1. Okay. 3 minus, which one previous distance to the 2 is 3 minus 1. What is the previous distance to the 3? Previous distance to the 3 is 3. So it is 3 plus 1. So it is 4. So it is finally 2. Okay. Minimum among all of them is the 2. So this is the distance what you have got. Okay. In the next iteration. That is when the k is equal to 3. So now you can write. So it is 0, 1, 3, 5, 2. So this is the distance vector. So here how we are moving, 1 to 1 will be 0 and 1 to 2 I am moving like this. 1 to 4, 4 to 2, 4 to 3, 3 to 2. That is 5 minus 2 minus 2. That is minus 4. Here it is 5. So it is 1. So that's why the distance what we are getting here is the 1. Then 1 to 3 how I am moving? 1 to 3 we are moving like this. 1 to 4, 4 to that is previous distance only we are carrying. Here also there is no change. Here how we are moving for the 5, so it is 1 to 3, 3 to 2, then 2 to 5. So 5 minus 2 is 3, then 3 minus 1 is 2. So that's why it is 2. That's why it is 2. Like this we are moving. Next iteration I'll move like this. That's it. Next iteration we can move like that. Okay. So I'll compute for the next iteration. Now for the next iteration I have to use this one. D3 of the U I have to use. So to the this one, to the 2. So what is previous distance to the 2? It is 1. It is 1. Then min of 2 incoming edges. Previous distance to the 1 is 0 plus 6. Fine. Then previous distance to the 3. Previous distance to the 3 is 3 only. 3 minus 1. So it is 2 only. So minimum is 1. So again there is no change for that. Now D4 of the 3 is previous distance to the 3 is 3 only. Previous distance to the 3 is 3 only. Minimum of, so 2 incoming edges are there. One is from the 1. So it is 0 plus 5 and one is from the 4. What is the previous distance to the 4? It is 5. 5 minus 2. So there is no change. Again it is 3 only. Now for to the 4, what is the previous distance to the 4? It is 4. Previous distance to the 4 is 5. Therefore 5. Minimum of only one incoming edge is there. That is distance till 1 is 0 and plus 5. So it is 5. So there is no change again. Previous only. Then to the 5. What is the previous distance to the 5? This will change. What is the previous distance to the 5? It is 2. Previous distance was 2. Correct or not? Previous distance to the 5 is 2. Now minimum of, so 2 incoming edges are there. One is from the 2. So what is the previous distance to the 2? It is 1. So it is, previous distance to the 2 is how much? 1. So it is 1 minus 1. From here to here is minus 1, comma. Now one more edge I am having from 3 to 5. What is previous distance to the 3? It is 3. Then plus 1. So 1 minus 1 is 0. So what is the minimum distance you are getting? It is 0. So minimum distance to the 5 is 0. So now again you write it here. It is 0, 1, 3, 5, 0. So that means from 1 to 5, how I am moving? So I am moving like this. 1 to 5, 5, minus 2, 3, then minus 2, 1. 1 minus 1 is 0. So with a distance of 0 I am traveling from 1 to 5. With a distance of 0 we are traveling from 1 to 5. And 1 to 2 how I am following? Like 1 to 4, 4 to 3, 3 to 2. So the distance will be an 1. And 1 to 3 how I am moving? 1 to 5, 1 to 4, 4 to 3. So the distance is 3. And how I am moving it to the 4? There is no other go. It is 1 to 4 only. So it is fine. Like this we will be computing the shortest path from the source vertex to an all other vertex. It is very simple. And 2 more examples are there in my notes. Go through that. And it is not that you have to follow the same example what is there in my notes. Whatever comes to your mind, you write the graph. Okay. I will also, while explaining, I will explain like that only. I will not see all the notes and I will explain. Whatever comes to our mind, usually we will explain like that. But for this, I have taken that same example. Why means it considers the different possibilities. So it is easy for you to understand because all type of the possible concepts can be explained along with this example. So usually whenever it is a prims or a Kruskal or any other algorithm, so don't depend on a single graph. You, whatever comes into your mind, you draw that graph and try to understand how this prims works, how that Kruskal's works and all those things. Okay. And whichever the lab programs I am explaining, all of you execute those lab programs, and if you are having a record with you, you can write it.